Hello, everybody, and welcome to day 3 of week 2 of this extra shoot camp, right? So today I'm really excited as we'll be doing some great stuff today. And today in particular, we'll be looking into a very important component that is, most of the times used to give physics to your game objects. And that is used for collisions for your game objects, right? And that component is rigid body component. So today we'll be taking a deep dive into the rigid body component. We'll be learning about the properties it has, the functions, the methods it has, and what actually can we do with it. Also, we'll be having a look at rigid body as on how can we use the scripting API, right? That is, how can we use scripting to access the properties of rigid body and what can we do with it, okay? So let's get started. But before that, let's just have a quick recap about what we did in our last session. Okay, that was day 2 of week 2, right? So in day 2 of week 2, we did how can we actually take input from the user, right? We learned about that, and that is something really interesting as we created our own cube, right? And we added some functionality via script so that we can actually move the cube, right? We can actually move the cube, that too with the help of scripting, and after that we used the user input as well. All right. So if you want to just have a basic look about what we did last time, we created this user input script, and there we use some simple documents, right? Just a second. Why is this not opening? Yeah, now it opens up. Yeah. So there we use simple, simple input methods, right? And we got the position of the cube. We took the axis, horizontal axis and stuff, right? We got input from the horizontal axis and the vertical axis, and then we applied this to the position of the cube. Okay, so first we used the cube transform dot position. After that, we took a look at a method that is known as translate method, which automatically, gives the position, adds the, we don't have to do this addition part, and it automatically basically moves the object in the given vector, right? Also, we had a look on the time to delta time, right? Why we used it and what exactly does it do. Okay, so now today, as I already told you, we will be having a look at a very important component, that is the rigid body component. Okay, till now, if you see, if we go to this cube in the scene view, if we increase its Y position, right? We have increased its Y position to 4.5, right? And as of now, we just have transform component, mesh renderer component, and collider component, right? Let's click on play. Let's see what happens. Will this cube fall or will this cube stay? So this cube basically absolutely stays in its position, right? There is like, it's in the mid-air, right? It's not falling. But that's not how real objects work, right? Real objects, if you have a ball, if you suspend it in the air and you leave it, it will fall down, right? Why? Gravity, of course, right? So how can we add this physics, to work on our objects in our game development, in our game application or whatever experience that we're creating? What can we do? So we can use a rigid body component. Till now, we have just had some, look at it earlier in our earlier sessions where we just use it to add the gravity. But let's see what else it is capable of, what it can actually do. Okay. So let me hit play again so that we come out of the play mode. And let's simply come here on the cube and add a rigid body. Okay. So now we have a rigid body component. So as soon as we add this rigid body component here, right, even without any scripting or even without doing anything, we've already, come up with a few preset properties. And one of them is use gravity, which is checked, right? So now this will actually behave as a real life object, and this will actually fall because physics will be enacting on it. So its mass is 1, its drag, that is, drag is friction, fluid friction, right? Like friction from the air, and if it's in water, right? And then we have angular drag, which is the rotational friction, right? Then we have kinematic, we'll look into it. Interpolation, collision detection is also there. Then these are constraints. Okay, we'll look into all of these. This is the info. Okay, this is the info about the game object, like what is happening. Okay, so let's see. As soon as we hit on play, let's see what happens. First and the foremost thing that should happen is this should fall, right? And this happens, right? because we are using gravity. Okay. Another thing, if I again move it up, right, and it will fall. So you will see as it's falling, its speed increases, right? Because it's falling, right? Its velocity also changes. Angular velocity doesn't change. If I rotate it, then the angular velocity is also affected. Okay. So this is info. Basically, this gives us the info about the current state of this rigid body. Okay. So first and the foremost thing that we just did was adding this rigid body, and as a result of it, without us doing anything, we can see gravity is working on it. Okay. Also, another thing that I would like to point out here is till now, whatever component we want to add, we have been adding by this add component, or we have been creating a script here and adding it, right? What if we want to add a component on the runtime? That means like when we are in play mode, okay? And now we want to add a component. What happens then, right? So, and that too without editor, by a script, okay? So let's try to add a component without using the editor and via script. Okay. So we have controller. Again, we can use, maybe let's use this user input class itself. Okay. And let's go here and let's say as soon as this starts, okay. So we already have the references for the cube set here, right, in the editor. So as we will say, as soon as the script starts, kindly add a component. So how can we add a component? We can say game object dot, as we used to do get component, right? This helped us to get the specific type of component. Similarly, this add component helps us to add a specific type of component, okay, on the game object. So we want to add rigid body. So what this shall do is, this shall simply add a rigid body on the go, right? As soon as it starts, okay? So let's see this in action. So this is a new thing that we're learning today, how to add a component via script itself, okay? We're not adding rigid body. So let me click on Q, and here you can see in the inspector window, all the components here. As soon as I click on play, okay, you would see a rigid body component added here. Bam. Here we have a rigid body component that was added on the go, on the fly, without using the editor. It was added via script. Okay. So that is how we add a rigid body component or any component. Okay. But as soon as we get out of play mode, this will be gone, right? Because this was added in the play mode via the script. So again, if you click on play, again, this will be added. Okay. Yeah. So for the time being, this was just for demonstration purposes. Let me remove this and let me add it here so that it's permanent and you can actually see the things happening in the inspector window. Okay. Now let's see what else can we do. Okay. Let's see what else can we do. First of all, let's try to again simply get the properties, the values of the properties by scripting. Okay. Then we'll try to set the properties. Okay. Then we'll want to learn about new properties. Okay, what this rigid body has to offer us. Okay, so let's go to scripting again, and here we want to, we want this code to be only executed when we press a specific button. Okay, so that we know what's happening. Okay, key down, get key down. Okay, we have to give the keyboard here, keyboard dot, let's say u. Okay, so as soon as we press u, this code will be executed. And here again, let's make a variable, as we made a variable for transform, right? So for example, if you want to, another learning that you can have right here is, for example, if I want to, write down, or get, fetch, write the values of different properties of the rigid body component. Let's say mass. Okay, then let's say maybe speed, or what else was it, drag. Let's say gravity is gravity on let's say kinematic. It's kinematic. Okay. So one thing that we can do is every time we can write cube dot get component to get the rigid body component and then say mass. Okay. Again here, what we'll do is we want to get the drag. Okay. So we can say maybe drag. Then here we want to get the, if its gravity is enabled or if it's using gravity. Again, if we want to get is kinematic. Okay. That if we want to get multiple properties, right, from the game object, we can do this. Okay. And this surely works. Let's see. Let's see this in action as well. This surely works, but there is an issue, or this is not the best approach to do things. Why? We'll look into it. Okay. So as of now, as soon as I press U, everything we're getting the mass 1, drag 0, gravity is on, true, is kinematic is false. So for cube, gravity is on, is kinematic is false, drag is 0, mass is 1. Okay. But then what's the issue? If we are getting everything that we want, then what's the issue? So the issue that I would point out here is that this is computationally more expensive. Like we are doing repetitive things again. Instead, we can save some computational power, right? We can save some computing power. Like how? So every time we are saying that, get hold of this cube, find find its component, this rigid body, and then get its mass. So when we say get component, what it basically does is it gets to this object, game object, and then goes by every component it has. Transform, no, it is not rigid body. Cube, mesh filter, no, this is not rigid body. Mesh render, it checks with every component. Okay, as soon as it gets rigid body, it assigns it. Okay, yeah, this is rigid body. Okay, but we are doing this again and again, right? For getting drag, again we are saying, okay, find rigid body again. So it will again go to cube and it will say transform. Okay, no, this is not rigid body. It will again go through all the components and then find rigid body. So this is expensive, right? It has to go again and again, again and again. So if we know that we have to use multiple times this rigid body, what we can simply do is we can simply create a variable of type rigid body and name it cube rigid body. Okay. And in the start, we can say cube rigid body. Okay. You have to name it cube rigid body, right? So cube rigid body is equal to, and we can do this here itself, get component rigid body and done. So now this, when this line of code executes, it will go through all these things, right? And as soon as it finds rigid body, it will assign it here. So now we have saved that. Okay, you have found out the component of rigid body, save it in this variable cube rigid body. And now instead of all this doing this finding thingy again and again, we can simply use this cube rigid body, and this will save us time and energy because this won't go again and again through the cube to find the component rigid body, to check, okay, where is the component, right? Because we have already found it. I mean, we have already saved it in a variable, and now we are just accessing the properties. Okay, so let's see if this works, right? So there should be no changes in the execution, like there should be no changes in the result of it. But this is a better way because inside it, it's doing less work, right? So now if I click view again, we have everything as it should be. Okay. If I turn on is kinematic, clear the console and again press U, is kinematic will also be true. Okay. So this is how you should do things, right? Because doing this again and again, get component, get component, get component, it will have to go again and again through every component, check, okay, if it is rigid body, okay, no, yes, no, yes. And when it finds rigid body, then it will again say, okay, let me get the property mass or drag or anything. But if you want to get multiple properties, there is no point of doing this rigid body again and again, finding the component. If you have found it once, save it somewhere. Okay, yeah, here is the rigid body. And then you can access all the properties you want to. Okay, so that is one quick tip that I would like to give you, because when you are working in big projects, these all things matter, right? And this can actually slow down your performance of your application or experience, right? So now moving on, let's get to know about a few more things. Okay. So what else, rigid body gives us? What other functionality does rigid body give us? Only just use gravity or is kinematic? Only the functionality that is shown here? No, that's not the case. We know about that, right? Not all properties, not all functionalities are shown in the editor view, right? For a component, if you want to know about other properties, simply Google it out and type rigid body Unity. Okay, and we shall be directed to the scripting API in Unity documents. And here we shall see multiple properties, all the properties that we have, and what happens if it all the properties if we have, right? So let's see. So here we have multiple properties: center of mass, constraints, detect collision, drag, freeze, rotation, and whatnot. Okay, so let's have a look at these. So before going into diving into different properties, let's see what all things we have here. Okay, so here we have something known as freeze rotation, freeze position. So what this means is if we click on it, if you freeze it, so this will actually freeze the rotation or the position in the given axis, and it will, even if the gravity is working on it, it won't change it won't let it change its position or rotation, whatever you have clicked here. So for example, here this cube is in the mid-air, so its y position is high, that is 8, right? Now, if gravity is to work on it, this should fall. That means y position should change. But we have set freeze position in y-axis. So then what happens? Let's see. So this shall freeze the position in y, and this shouldn't fall, right? So now, although gravity is acting on it, but we have given it a constraint. We have said no, freeze your position in y-axis, right? Similarly, if we remove this constraint, this will fall, right? Okay, now let me again give that constraint and let me rotate it a bit. Okay, let me use the rotate tool and let me rotate it. Okay, on the x-axis. So now if it falls, see, it falls and it rotates as well, right? Again, let me take it upwards and change its y rotation. Okay, and let me say freeze rotation in y-axis. Okay, so now you would see it will fall, but it won't change its position, its rotation in y-axis. It shouldn't. Okay, let's see. And it stays right there. It doesn't change its rotation because we have said to not change the rotation in x-axis. Okay, so this is how this freeze position and freeze rotation work. This is constraints work. Okay, then we have collision detection. Okay, so this is used if you have a rigid body on a component. We can actually detect collisions. Collision means when you're actually colliding. Colliding means when you're touching another object. When this object is touching or colliding with another object. Okay, so this is discrete collision, continuous, dynamics, continuous, speculative. Okay, so these are the ways of detecting collisions. Okay, so discrete will be taking it like after certain intervals it will be checking. Continuous will be always checking. Okay, and similarly continuous dynamic and continuous speculative also have some changes in it. Okay, so let's say continuous detection, and let's say if you want to do in your game you want to change something, like we want to change the color of this as soon as hits the plane. Okay, so for this, what will be steps? Whenever you want to achieve something in your application or experience, think it in small steps and see what and how can you do it via Unity, via your game engine. So here what we want to do is we want to change the color of the cube as soon as it hits the plane. So there are two things. First, change the color of the cube. We know that. Yes, we know that. We can simply access the material property in the mesh renderer and change its color to whatever we want. Step one, we know that how to achieve that. Step two, you know, we have we have to change it only when it hits the plane. So how to detect if it is hitting the plane? Okay, how to detect if it is hitting the plane? So for that we have a few functions. Okay, and which are on collision enter, on collision exit, and on collision state. So these are three functions. Okay, and these functions are to be called automatically whenever this object, whatever this very object on which script is there, this hits any other objects. As soon as it enters a collision, this will be called. As soon as it exits a collision, this will be called. As soon as it stays with the collision, it is in the collision, this will be called. So let's see. Let's say debug.log collision enter. Similarly, let's say collision exit, and similarly collision stay. Okay, so basically, if you want to see it in stepwise, this should be like this. Okay, so one state could be just entering the collision. Another state could be it is like colliding as of now. Another state could be it is just it collided and it has exited the collision, like it's no more colliding, right? So let's try to see what happens. Okay. So now in console, as soon as we click play, we have this should fall, right? No, this won't fall because we have freeze rotation in Y. Okay. Now we'll see, we'll say don't freeze the rotation and it should fall. And as soon as it touches the plane, we don't get any, debug. Why? What's happening? Why are we not getting anything? Right? So first of all, we have to see that this plane also has a collider. Yes, this has a collider. This cube also has a collider. Yes, this has a collider. Then why was this not called? Okay, we have saved the script as well. So let's again go to Google and simply write on collision enter Unity. This is how you'll learn actually new things, and you can see what's happening, why things are not being called up, why things are not being done. So here it says if collision, okay. Hmm, right. So here you would see on collision enter, we are saying that we have something, this collision, and this collision will have multiple, things. Okay, so this is on collision enter. Okay, and there is one thing known as on collider. Yeah, this is on collision enter. Okay. So what can we get out of this collision? So collision dot game object dot name. Okay. So let's try to print the name of the collision. Okay, and let's go here and let's see. Okay, okay, yeah. Now we know why things are not working, because this user script on it is on this very game object. Okay, and we want this collision and everything to happen on cube, right? So we need to have the this on collision enter and every this script or this code on the game object, right? So let's create a new script. Okay, and let's say rigid body testing. Okay, let's add this script to the cube itself. Okay, now we have this. Let's open this and let's take these and add it to this. So now this very script is on the cube. Okay, yep. Save it. Yeah, on collision enter, and this is on rigid body, and let's see how things roll from here. So on cube we have a rigid body, we have collider, and let's play. Let's on the cube, let's say okay, do not freeze rotation. and done. We have something. Okay. So first of all, we have multiple, this collision stay. Okay. So here we have collision enter plane because we entered the name of the collide, like whatever this collided with. Okay. Then it says collision stay, 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 and it's staying there. Okay. And as soon as we move it, it says collision exit. Okay. Let me reach position and Y, and it says here collision exit, right? As soon as the collision ends. Okay. So this is the way we can actually detect things. Okay. Detect the collision. So what we learned right here is all these methods should be on the game object which has a rigid body. Okay. So we, as soon as we put this script on the cube which has a rigid body and a collider as well, things work. Okay. Now on collision enter, we have this given to us here. Okay, this is an argument. So whenever the collision happens, Unity automatically puts everything into this collision, all the information in this collision, and with the help of this collision variable, collision type variable, we can get the name, get the type, of get whatever we want to from this name, from this collision, collision variable. For example, we just find out collision.gameObject.name. So like, with which object does this cube hit? Give me the name of that. Okay. Now, what we want to do is, as soon as this enters, right? As soon as it enters the collision, we want to change the plane. Okay. And let's not put, debug anything on exit and stay. Okay. So we want a plane, right? We want to change the plane. So first of all, we can make a public, game object, maybe public reference for the plane. Okay. And here we can say, okay, we don't actually want we won't want this, right? Because we are saying as soon as this hits the plane, okay, we can say change the color, right? So what we can say is this dot game object. What this would mean is, this means the very game object on which the script is residing. So which is a cube, right? We can get the mesh renderer component. And then we can say get the material property. Okay. Then get the color property, and then set the color to maybe cyan as soon as it hits the plane. Okay, so let's see that in action. Let's unfreeze the rotation, unfreeze the position. As soon as it hits, color changes, right? But so have we achieved what we wanted? Looks like so. Okay, this pretty much looks like it. But what if we have a cube here, another cube here, and we click on play, and as soon as it hits, now also it is changing its color. Why? We wanted to change its color whenever it hits the plane, nothing else, right? But why is this changing the color? This is so because this is doing whatever we said it to do, not what we said, what we coded it to do. So here we just said whenever it enters collision, just change the color. We didn't say do a check or something like that if it's a plane or not. Okay. So what we can do is we can say to only change its color when the game object is the plane. Okay. So we can say collision dot game object dot name is equal plane. Okay. Then change the color. Okay. So we are saying if the game object that it is this cube is hitting, its name is plane, this very object, right? We are saying this name, its name. Okay. Then only change the color. Let's see if that works. Yeah, now it's hitting. It says collision enter cube 1, but it didn't change the color, right? Let's drag it here. Yes, it does change the color. Okay. So this is doing exactly what we want. Okay. So what, again, here is a better way of doing this. Okay. So here we are using collision.gameObject.name. What if, while playing, while doing things or whatnot, we change this name to ground. Okay. Maybe, right? And now if we run this, will this change the color? On cube, it shouldn't, but on plane it should, right? But it doesn't. Why? Because we have specifically said whenever the game object's name is plane, then only do this. And as of now, we have changed the name to ground, right? So a better way of doing this is you can actually use tags. This is what tags are used. Okay. So you would say here it's a tag. There are multiple tags. You can add your own tag. Okay. Let's add a tag and let's say my plane. Okay. Let's save it. And now ground, go to ground and tag it my plane. Okay. Now, no matter what name you give it, right? This tag will always remain same, my plane, because we have given it. Okay. So in our script, we can say instead of checking the name, we can get the tag. Okay. Collision.gameObject.get tag is equal to my plane, right? And also we just saw here we have something known as compare tag. Okay. And this basically compares the tag, right, with the given tag. So it's better if you use this very function. Okay. So now this will compare the tag. So it will compare the tag of this game object with this very tag. Okay. And if this is the tag, then it shall change the color. Okay. Let's see if that works. So let's click play. Let's hit play. This falls. Now it falls. Boom. That's working. Right? Okay. Again, and freeze its position. This will take it above. And let me maybe change its color. Right? Okay. And now let me change the tag of this ground to maybe untagged, and let me change the tag of this to my pin. Okay. And let me unfreeze the rotation. So now it falls, nothing happens. It didn't touch this cube, right? And it did touch the plane, but plane's tag is no more my plane, right? Now cube, but this cube's tag is my plane. Okay. So as soon as it touches it, it changes, right? So that is a simple, implementation of collision. We have just seen how collisions work, how we can actually detect the collision, how we can get to know, okay, this is a collision. And if you want to do specific tasks, like we simply did a simple example here, that is change the color of the cube as soon as it touches the plane. Okay, let's make it more interesting. What if you want to change the color of the cube to whatever it hits, or maybe, yeah, let's make it whatever it hits. Okay, so what we can do is we can say, so we can make a maybe mesh renderer, okay, and what we can say is we can get the access to the game object, right, to whatever it is hitting by this. Then we can say if we have the game object, we can access any component it has, right? We can say get the game object, get the component mesh renderer. Okay, and we can also say get the material and get the color. Okay, and instead of making it mesh render, let's make it color. Collider color. Okay, so what this is doing, whichever object we hit, it's saying it's getting the game object because it's saying this is a collision variable. Okay, from collision variable I can get the game object what I'm hitting. Then from that I can simply find the mesh renderer and then the material and then the color. So this will store the color of any object this cube hits in the collider color. And simply we can say set the color of the cube to this collider color, right? Right. So what this shall do is if there is a red cube, a red sphere, and a cube falls on it, okay, what will happen? This on collision enter will be called, this line will be called, this will say, okay, the name of the game object, sphere maybe. Then in this line it would say, okay, we have the game object, get its component mesh renderer, then the material and color. So if this is a red sphere, color red will be stored in this collider color. And then this line will be executed where we are saying change the color of this game object, like cube, this game object, and change the color to the collider color. So the color of the cube should change to whatever color we have here, which is red. Let's see this very thing in action. Let me put it here. Let me add a sphere. Let me reset its position. Okay. Let me put you here. Let me again create a duplicate a sphere, put it here, right? And now let me give it some materials. Okay. So let me give it cube mat 1 to the cube, and maybe let's name it sphere mat to the sphere. Let's again duplicate it, sphere mat 1 to the sphere. Okay. So for cube 1, let me change the color to, okay, no, not black. Let's not go dark. Okay. Then for sphere 1, let me change the color to blue. And for this very sphere, let me change the color to yellow. Okay. And now let's see what happens. So we have coded this cube to get the color of whatever object this hits, right? So as soon as it hits the sphere, its color is yellow. We have got a yellow color. Now, as soon as it hits this cube, we've got the cube color, right? So this is rotating because we have freeze the Y position, but rotation is not fixed. That is why it is rotating. And it's going left as well because the X position is not fixed, right? So now we just saw, now it touched the plane. That is why its color is green. Okay. So let me make it more fun. Okay. Okay, what we do it. Okay, okay, freeze position, rotation, everything. Freeze everything. Okay. And here we are saying it 0, 0, 0, 0, and we are asking it touch the plane here first. Okay. We are saying let it fall. Okay, so this was not directly above the sphere. Now it should be good to go. It falls. And it falls on the cube. And if it again freeze, right? As soon as it touches any object, it changes its color. So yes, we have achieved what we wanted. So in this video, till now we've seen at collisions, at rigid bodies. We have also seen how we can actually add components by script. Okay. And we also saw that how can we actually interact with the collisions, right? Okay. So this is more or less about rigid body. These were one of the, or some of the most important properties of rigid body. And for this session, we'll be looking into these things. I would give you, homework, maybe you can say, and in the homework, you can explore other properties, right? First of all, create your own stuff, try to recreate the same example on your own and try to detect collisions, okay? And try to do something, change the color, change the size, change the position or anything whenever collision happens, okay? Maybe when collision enters, when collision exits or whatnot, okay? Then try to change the property of the gravity, with your input. Maybe you press G, gravity stops acting on your rigid body. If you again press G, gravity is working, right? So that is all from my side today. And today we had a look on rigid bodies. There are multiple more things left, to look at rigid bodies, but we won't be diving deep into that because we will be learning about all those things on the way, on the go, right? Today, I wanted just to give you a brief idea about what rigid body is, how it works, and majorly collisions, and how can we use collisions. Okay, so that's all from my side. See you guys soon. See ya.